Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to show you more about incorporating wave radiation and diffraction hydrodynamics from the Shipmo 3D toolset in a ProteusDS project. So, where we last left off, we'd calculated the radiation and diffraction hydrodynamic database, and we're going to use this in ProteusDS Simulation Toolbox. So, we'll make a brand new ProteusDS Simulation Toolbox project. I'm just going to save this right away here. Under Ship Motion Projects, we'll make a new folder in here. And just call it Square Barge. So we will need to make a rigid body to incorporate all of the hydrodynamics. Square Barge here. And we'll need to copy the hydrodynamic database and also the full visualization mesh that we created in Rhino earlier as well. And I'll show you how to add all that. So we've made a new rigid body model, but the problem is that it's completely empty. You can see a little indicator for the center of mass, but we haven't added any hull features or anything like that to it. So the first thing we'll do is we'll add a rad diff hydrodynamic model. We'll call this Square Barge HDDB. And we'll go to, when we right click and go to feature definition, the feature is not recognized in the library, so we have to create it. And the hydrodynamic database file here, we can literally just copy and paste it from the file that we created moments ago in Shipmo 3D, and there it is. Now you'll also see some options here for incident loading, diffraction loading, wave radiation loading, restoring loading. You can actually turn on and off different functionalities from the database. So this is the incident wave excitation loading. This is the diffraction loading only as separate. So this is the loading from the effect of the deformation of those waves around the hull of the incident waves. The wave radiation loading, that's the effect of the waves radiating as the body is moving. It's creating waves essentially when it's doing that, and there's resistive forces on the body from that. The restoring force loading, this is the hydrostatics and restoring force from the weight from that vessel as well, from that hull. And resistance, this comes from those resistance coefficients that we put in. So we'll go back to here, and we do have an option of locating this, but the way that we're setting everything up is having the rigid body frame located at the transom at the aft location, so we won't need to change that value. We will need to put in mass values and mass moments of inertia. What I'm going to do is put in the value of the mass of the displaced 20 meter by 20 meter by 1 meter slab of water. And I'm going to put in, assuming a radius of gyration of 1, it's going to be all very symmetric. The focus of this tutorial is more about showing how to incorporate the hydrodynamics into a general project and not necessarily the specifics of this hull, but it does get fairly dominated by those effects. The other thing you need to do, you do need to specify where the CG location is, and again, it's a 20 meter by 20 meter box, so that's going to be 10 up, and with in Proteus Simulation Toolbox we have positive Z down, so we'll have a -1 here, and this parameter define inertia about CG. I want Proteus to understand that these are expressed about the CG location, so we'll set that to 1. So we'll save that. So things are so far so good, but again, we don't have any visualization of the hull itself, and that would be really nice to have. So we're going to take advantage of another feature in here for visualization, the visualization model. Square Barge. I'm going to add this visualization model. Visualization, I'm going to call that feature Square Barge visualization. Now I haven't added this specific feature yet, so when I right click on it, I'll be prompted for the name of the feature we want to create and everything in here. So and the only thing in here is the file path to the actual hull, the OBJ hull file. So this is not used for any hydrodynamics calculations. It's purely for visualization. So it's nice to have that in there. Now there will be a difference in the way that we had the hull oriented. Remember, we had a positive Z up interpretation in Rhino and for the purposes of the Shipmo 3D toolset. So we use these 6 values to create an offset here, XYZ frame offset from the rigid body frame, and roll about X, pitch about Y, yaw about Z. And I believe if we just put in 180 here, everything will line up perfectly. So we just flipped it around the X-axis. And in the visualizer view here, you can turn off the mesh panels and sort of see inside the mesh to make sure everything's looking good. So that little soccer ball thing that's showing where the center of gravity is, that's right in the middle of the box. That's right where we want it. Here you can see our the rigid body frame in the aft and the transom here. So everything is looking good and set up like that. Now the next thing you should think about is just doing some basic testing to make sure this physically is making sense. And there's a number of ways you can do that. I encourage you to have fun with it. So what you do is you can specify the state of the rigid body, and what we'll do is just do a decay test. We'll put it a little bit up in the air. So you can see we've got the water surface there. There's a little bit of a gap, and we'll just run a really quick simulation here. It runs 60 seconds pretty darn fast. And what we expect to see with so much wave radiation effects is that the system gets damped fairly quickly, especially in heave. So there's our box. You can see in ProteusDS here, we've got a little air gap. It's starting off in the air. That's the main thing. And as it plops into the water, of course, there's hydrostatic restoring stiffness as well, but you can see a tremendous amount of damping from the heave wave radiation effects. Now, it's important to note that ProteusDS doesn't render the wave radiation effects, so we're not seeing any of that. We will see the incident waves, but we won't see any diffracted or wave radiation effects in here. So, within 20 seconds, this barge is totally damped out. It's not tilting anyway. It's not pitching anyway funny. We expect to have a nice uniform heave decay test, so that was looking pretty good. So I'll leave this here. I'm going to show you a trick with ProteusDS. Now we can do other tests with this as well. Now these tests, we're just making sure all the reference frames are lined up and everything physically meets our expectations. So another thing we can do is a pitch decay test. So we'll set this to 15. Sorry, that was the rate of rotation. Let's set the pitch to 15 degrees. There we are. And this will have it heaved up in the water as well, but what I really want to see is just mainly this this flapping action. Oh yeah, let's set this back down to 0. That'll help a little bit. Okay, so we'll save and run the simulation. So it's gonna, with this big pitch angle, I expect it to just decay out in pitch. So the trick I want to show you in ProteusDS is if you go back up here and go attempt to reload everything, it's just kind of a lot faster to get into this, see this view here. So yeah, we got a little bit of heave motion, and ultimately what I was looking for here is the decaying action in terms of the pitch motion decaying out, and it certainly looks like we're getting some pretty strong wave radiation effects here that are calming everything down in pitch. So after about 20 seconds, again, most of the motion is decayed. If you really want to, you can do some plotting in here, orientation through time. There's some pretty big transients here at the beginning with the pitch angle decaying, and then, it's basically gone back down to 0. So this is all of these hydrodynamic effects are coming from the hydrodynamic database from the Shipmo 3D toolset. There are a lot of hydrodynamics that Proteus will calculate natively itself, but that's the topic of another video tutorial where we explore that a little bit, make comparisons to this, and show when you might want to mix and match hydrodynamics between the Shipmo 3D toolset and ProteusDS. All right, thanks for watching.